back? Give me a wave if you can hear me at the back. Lots of waves, fantastic. Good morning, my name is Matt Wood. I'm the General Manager of Product Strategy at Amazon Web Services. That slightly strange title means that I get to come and talk to smart people such as yourselves about how you're using cloud computing. As you heard from my introduction, we've been working with Spark and AmpLab for a number of years, and so it's great to be on stage here and join such a large and vibrant conference. This always tends to get left to the end, but thank you all very much. I know you've got a million things to do and a million emails to read and a million different places you could be. So it's a privilege really to be able to be here and talk to you a little bit about some of the work that we're doing at AWS and some of the work that our customers are doing with Spark in the cloud. Before we get there, I want to talk a little bit about just technology adoption. This is something that I'm sure a lot of you have heard a lot about over the course of these 2 days. Spark is an emerging and an exciting technology. It's being adopted in production across a myriad of different use cases. And you can look at technology adoption in a lot of different ways. I'm sure that you and your teams have your own approach to technology adoption, downloading the binaries and trying them out or spinning them up on EC2, anything like that. Or you can take the more formal approach like the Gartner Hype Cycle, which looks at technology triggers and then heightened expectations and then dramatic things like disillusionment and plateaus of productivity. But one thing that I've noticed as we've been going through lots of different technology shifts is one of the defining inflection points of technology adoption is the answer, a well-understood answer to the question, what is X? So we saw this many, many moons ago with the question, what is cloud computing? And lots of people, different people had lots of different answers, but the answer that became most well-known and most broadly distributed was that there's really three flavors of cloud computing. There's infrastructure as a service and software as a service and platforms as a service. Now, whether you agree with that or disagree, it was an inflection point for the adoption of cloud computing when this definition became pervasive. And we saw exactly the same thing when it came to big data 5, 6, 7, 8 years ago, when the answer of what is big data became more and more well-known, became more and more distributed across people that were working with it. And this is true when I actually did a search when I was preparing for this talk on SlideShare for what is big data. You can see here that there are 431,000 presentations which talk about what is big data. And I used to joke about when you asked what is big data to a group of data scientists, if you asked 100 data scientists, you get at least 101 answers that came back. And I think this is true. Now, I didn't go through each one of these. I had a quick skim through some of the early ones. But it seems that the pervasive distributed definition of big data comes down to these three things. I'm sure you've all heard this before: volume, velocity, and variability. Now, whilst this was originally intended to define the characteristics of data, that data was increasing in volume, that it was coming in more and more quickly, and that it was becoming more and more complex and variable, what's happened over the years is that these have also become to be seen as constraints of working with the data, that the volumes were becoming too large, that the variability was becoming too complex. And there were certain vendors that would perpetuate these myths in order to try and sell you more and more hardware. But these constraints are totally understandable if you're operating in an environment where your data center walls cannot move. What happens is that these constraints become more and more boxed in terms of how customers deal with the data that they want to work with. They move from an environment where they are asking questions which are going to be impactful to their business, and instead ask questions like, given that I only have 100 terabytes or 100 cores, what can I get away with asking? Or, even more insidious, what if I'm in a queue on a shared resource? What do I have to do, and what resources do I have to request to get me off the queue and into the cluster as quickly as possible? Now, this is a crazy way of working. It's completely boxed in thinking, and it limits the opportunity that you have to do extraordinary things with your data from some of the talks we've already heard from. What we see when customers start to move into a cloud computing environment, whether it's on vanilla EC2 or on Elastic MapReduce, Hadoop-based distributed computing clusters, or using something like Databricks Cloud, you start to remove those constraints, and your thinking goes from being boxed in to starting to think about, well, what is the real question that I want to be able to answer? What resources can I draw down to be able to work with the data that I have, to aggregate that with other data sources and ask real questions? So I started to get thinking about what is next for big data. If volume and velocity and variability are no longer the constraints that they once were, we can focus in on the opportunities of those three things and start to really work with the data in a much more productive way. So it's productivity and the productivity of working with data, which is, in my opinion, the next era. We're moving from an era where we're just worried about collecting the damn stuff to actually putting it to use. And there's three areas of productivity. First of all, if you want to be productive with data, you need to be able to quickly provision the resources to work with that data. You also need to be able to have a perfect fit for the resource mix for the problem and the questions that you're trying to ask. So you need to be able to fit a square peg into a square hole, not a square peg into a round hole in terms of resourcing when it comes to the infrastructure, but also the tooling that you want to use. And increasingly, it's becoming more and more important that these productivity tools are designed for iteration, that you're able to quickly explore and work with the data in a way that makes sense. So these things, three things, the provisioning, the resourcing, and the iteration have become more and more important. And what we've seen from customers that run up on AWS is that their architecture, their data workflow, which is tempting to think about just in terms of the creation and the storage of the data, and then you want to compute and ask questions about it, and then collaborate around the results, are actually increasingly complex, increasingly sophisticated workflows, which include a lot of different tools, which include a lot of different resource mixes that really center around these three things: a canonical data store, streaming data of some kind, and a collection of what we think of as task clusters. These are clusters which are specifically tuned and optimized for a specific task. And so when I went off and started to look at some customers, we found that a huge number of customers are working with a Spark on Amazon EMR. EMR is Elastic MapReduce. It's a distributed platform which allows you to provision clusters very, very quickly. So these are all companies that are running Spark in production in the cloud today. And what I thought I'd do is we could talk about Yelp and how they're using machine learning with ad targeting. We could talk about Quixy, who have a app discovery platform. But I wanted to just pick three of these and give you a bit more of a deep dive into how their architecture fits together and try and be illustrative about the productive way they're working with their data. So we'll talk a little bit about the Washington Post. So the Washington Post, I'm sure you're all familiar, they have a website. They publish articles onto that website. And they are able to take all of the clicks, videos, and interactions from their website, and they drop that into S3. And then they use machine learning, so MLlib on Spark, to be able to create and detect and discover new customer segments. So these customer segments are then used in a couple of different ways. Number one, they're used to define segments which go to the ad buyers, and then the ad buyers sell those ads onto people that want to deliver ads onto the platform. In addition to that, they're also able to map users that visit their website onto those segments so they can deliver more targeted advertising. So that means as a consumer, you're happier because you're seeing ads which make sense, and as an ad buyer, you're happier because you're more likely to get those ads clicked on. But this isn't just an edge case. This isn't just experimentation. The Washington Post are deeply embedding this into their business. The ad buying and selling is a core part of the Washington Post business, and all of that is running on Spark, on EMR, on AWS. They then take all of those segments and use those to forecast the revenue that they're going to get from their website, again, using Spark. They're also able to use that canonical store of data that they have, those clicks that are coming through from their website, the videos and the interactivities, and they run more machine learning, not using MLlib, this is using something specific that they made, and use that for the recommendations. So they're trying to increase engagement on their website by having customers stay longer on their website by recommending articles that they might find are interesting. Finally, they're starting to work with Kafka. This isn't in production yet, but it's the next step, where they're starting to work with Kafka to take every single click that's coming from their website and push it into Spark to do the same machine learning and segment discovery. So again, this is a core part of the website on a very, very high scale. Hearst, I'm sure some of you are familiar with, huge publishing company. They're also involved in automobiles and all sorts of other things, but they have about 200 web properties. They collect all of the web analytics for those properties using a Node app, which is running on Elastic Beanstalk. And then they use Kinesis, which is a real-time streaming engine, to collect all of that click stream and, surprise, surprise, push that using Spark streaming into an EMR cluster running Spark. Now, they're interested in using Kinesis here because Kinesis allows you to effectively cache 24 hours of data. And that means that they can take that 24 hours of data, and if there's any downstream disruption with their analytics, the data's still there stored inside the Kinesis engine, and they can start picking it up again. And they process 5-minute windows at a time, about 100 meg that they throw into their Spark streaming on EMR, and they convert and run various analytics to convert that data to JSON and to CSV. Now, they used to use Pig for this. But what they found was they moved from the Pig UDFs into Spark using Scala. Any Scala people here? Any Scala people? Yeah, my people. So they were able to move from Pig into using Scala in Spark, and the whole thing got a lot faster. Now, what that meant was they were able to expand that window. So instead of they were able to work with multiple windows, multiple minutes in their window, larger blocks of data, and get more done in less time. They're also able to take, again, a secondary canonical store of their data and push that into another EMR cluster, which takes that data, loads it into a data warehouse and into Elasticsearch so that it's exposed to their business analysts and to some real-time searching that they do through Elasticsearch. The last thing that Hearst love about Spark is this iterative nature of the development. So they're able to take their streaming cluster and swap in and out of the code as quickly as they possibly can, and to be able to provide iterative improvements to their workflow. So a complex, sophisticated workflow which is continually improving. Finally, GumGum, which provide in-image advertising, they take all of their ad impressions and clicks and they throw it into a Spark cluster, which is running 24/7. This is not a bursty workload. This is running perpetually all the time. And they use RDDs in order to be able to take that data, store it in memory, and run multiple iterations of analysis over the same data in memory so they don't have to go back to disk. They use that for an interactive dashboard, so their product managers internally can take a look at the state of the business. They're also using that for revenue forecasting. They're able to take clickstream logs, again, from their canonical source on S3, throw this in this time into Spark clusters, which run in batch, and load that data into a data warehouse for business analytics. And finally, they're doing continual and iterative data exploration and testing. So they're able to continually spin up the clusters that they want, running the code that they want, to continually explore and run effectively ad hoc queries over arbitrarily complex, large-scale data sets. So what we see is that with Spark running inside AWS, we have very, very quick provisioning. You can get the clusters that you want at the size that you want. You have the right resource fit, because you can pull down high I/O and high memory and high CPU resources. And with Spark, you get a continual iteration. So we have here a perfect storm of productivity to allow customers to work more and more productively with their data at pretty much any scale. And so we got to thinking, how can we accelerate this? What can we do to help customers take advantage of the productivity of working with data? And so today, I'm very pleased to announce that we're adding Spark as a first-class citizen on Amazon Elastic MapReduce. That allows you to provision and scale managed Spark clusters up on AWS. So this gives you very rapid provisioning of Elastic clusters. You can provision new clusters in minutes. You can use a range of instance types, high memory, high CPU, high I/O instances. You can add or remove capacity against your running clusters. So if you suddenly find you've got an increase in utilization, you can just throw more cores at the problem. You can access those cluster instances directly if you want to. You can just log in and get directly into the clusters, into the instances. And the clusters themselves run inside VPC, which is the virtual private cloud. So you can keep them nice and secure in an isolated network environment up on AWS. Because this is running on EMR, you also can access data directly on S3. So when you have data stored in these canonical stores, you can access those objects directly from Amazon S3. That means that multiple clusters can run against a single code source, a single data source stored inside S3, and there's no need to copy or manage the data on the cluster when you want to start using it. You just start accessing the data directly from S3. You can provide your own and manage your own keys for server-side and client-side encryption with your own keys that sit inside hardware security modules up on AWS. And there's no requirement to use S3 if you'd rather use HDFS. You can just use and mix and match those two together. Finally, you can integrate Elastic MapReduce and Spark with something that we call the spot market. This allows you to bid on underutilized capacity on EC2. So EC2 is a very large computing platform. We manage the capacity under the hood as best we can, but we usually have underutilized capacity. Now, in terms of getting economies of scale, we want that utilization to be as high as possible. So we allow customers to bid on that underutilized capacity. What that means is, from a cluster and a Spark perspective, is you can name your own price for your cluster. So you can say, what is it worth? You can make a value call on what is it worth to run these analytics at this point or sometime in the future. This allows you to run at extremely high scale at a very, very low cost that you control. And it also allows you to run at the lowest cost possible for time-insensitive workloads. So if you've got something that it doesn't really matter when it runs, you just want it to run as cheaply as possible, you can set your price, wait for that spot price to be fulfilled, and the cluster will go off and spin it up. And if you really want to run on demand, you can do that as well. And we have reserved capacity pricing as well. So that's Spark on EMR, announced today. It's no additional cost on top of EMR. It's available today, and you can learn more at aws.amazon.com/EMR/Spark. Thank you very much.